Hello, and welcome to the latest installment of the Aras Innovator Demo Series. We're going to talk this morning about integrating and managing your CAD tool data with Aras. A quick note about the demo series: it runs for 30 minutes and features all demo with no sales pitch. Twice a month, typically bi-weekly, we show you a different capability of the Aras platform. Once the demo series is complete, you can always go to our website, www.aras.com/demo-series, to view the past demo as well as any upcoming demos. We have on the line today Raul Rosa, Product Manager. Raul, take it away.
Thank you, Nicole, and welcome everyone. Before we get started with the demo, I want to show a couple slides on Aras CAD management to get things into perspective. When we discuss CAD data management, the important business process is having CAD data managed directly in Aras PLM with automated part BOM updates coming from CAD, and this all tied together with enterprise change management and visual collaboration. It's important to make that when it comes to CAD data management, Aras is CAD agnostic. We have full suite of CAD connectors for all your major CAD platforms, for mechanical, electronic, and electrical CAD. Aras is a multi-CAD platform with a range of connectors to manage all of your CAD needs. With that said, I wanted to make sure that I introduce that and let people know of these connectors that we have for all the various platforms. We'll dive into the demo. Come into our SolidWorks. The focus of today's demo is to show how we store data and the real-life process really that an engineer goes through to store CAD data into Aras Innovator using an MCAD connector. Now, for today's demo, I will be showing an integration with SolidWorks with Aras Innovator using the XPLM connector for SolidWorks. For this demo, I'm going to use a simple assembly to illustrate the process and better highlight the steps for storing CAD data into Aras PLM. So what I have here is I have a simple crane hook assembly with some parts, a hook, a pulley, a side plate, pins, etc. So before I get started, what I want to do is I want to quickly show you my custom properties information. To notice, and I have a description already here filled in and mapped, and the revision part number. And the important point here that I want to make is that the capabilities to map properties between CAD and PLM, and we'll discuss that further down the road. In the process of storing CAD data into Aras, the process is really simple, utilizing a CAD connector. In our case here, I have an assembly and I'm finished with my design and I want to start to put that information into Innovator. So inside, our connector is built to be embedded inside the CAD tool, and you'll notice here on my toolbar I have the PLM connector for XPLM that's enabled, and I'm simply going to hit the save button. It's going to ask me to go through and log into Innovator, and I'll go ahead and accept those and log in. And then the process begins. Automatically what happens is the connector looks at the CAD structure, grabs that information, and is ready to put that into Innovator. Of course, I have the option here to go ahead and create BOM on the fly and generate a part, but for this demo, I'm going to take it one step at a time so really we can illustrate each of the steps and better understand how the process works. So I'll go ahead and hit save here. And what the connector is doing now, it's looking at the entire structure of the assembly, grabbing all that information, storing that into Aras Innovator. And that's it. The process is complete. So let's take a look at what happened. So I'll go here and display my CAD document. It's going to go ahead and ask me to log into Innovator, which I'm already logged in. So I'm just going to go ahead and swap here. And you'll notice what automatically what happened is it created a CAD document. And the CAD document, let's talk about that a little bit. The CAD document is the container for all your CAD files. So it's created on a one-to-one basis, one CAD document per CAD file, and it stores the related information of that file. You notice that I mentioned in the beginning the ability to map properties. And if you look here in this case, I have both the name and the description mapped to that CAD properties, and it's automatically pulling that information and filling it in our CAD document. The native file is automatically attached. The SolidWorks file is automatically attached to that CAD document, and the structure of the assembly is automatically understood and extracted and put in. Notice there's no part at this moment because we decided that we were going to create each step by step, and we'll go through that and explain. One of the things I also want to mention is that Aras, with our conversion server, we are able to generate PDF viewable for all of your CAD files, both 2D and 3D, automatically. So it's an asynchronous process that happens. Of course, this can be tailored to your needs, but in our case, it happens the moment we check it in or save it into Aras, the file gets automatically created. If I do a refresh here, what you'll notice is starting to happen is the server automatically understood that we have these files, and it's beginning to create the viewable for them. So if I go through and look at the CAD document for that, you'll notice that I have a thumbnail preview that's already been created. 3D PDF for the file has already been created as well. And if I switch into my visual collaboration, I'm able to go in and view the file right from the web. And this is all HTML5, so no plugins needed. And you're able to come in, rotate the model, get some information on the model, do some markups. It's a really nice tool to have, really, for the entire company. And those who are not engineers and not on the CAD platform get to take advantage of such functionalities. And as I mentioned, it's an asynchronous process. It's automatically created through our Aras conversion server. And I really want to talk about that quickly, because when we say the conversion server, it's really misleading, the name, because in actuality, what it is, it's a batch processor. You can deploy any solution on top of the conversion servers to be able to generate what you need. In another case, for example, for those who work in a multi-CAD environment that will need a translation between different CADs, whether it's Pro-E, Creo, SolidWorks, and you can tie that back in to have it automatically created for you and linked all to the right CAD item. Okay, so that's our CAD document. So what we've done is we've gone through and we stored the structure into Aras. We have a CAD document for each of the corresponding parts of the assembly. The next step is to create a part. Let's talk about that a little bit. So in Aras, we have two type of items. We have various type of items, but when it comes to the CAD portion, we'll focus on the two type of items: the CAD document item and the part item. So when we talk about part item, and it's important to explain this because a lot of times in the CAD world, when we say part, we're thinking in terms of the CAD file, the part file. But in this case, we're talking about the part item, or the item master, which stores all that information of the CAD file. And to do so, to be able to create that, the connector allows us to do that pretty easily. Of course, we can always create the part item separately and have it linked and assigned back to the CAD document. And this is important to mention because there are companies whose process involves creating or requesting a part number beforehand, before the actual engineering work, and then they will come back and link it back to the item in CAD. With that said, in our case, we're going to go ahead and create automatically the part numbers and the part item directly from CAD. So I'll come back to my assembly, I'll hit create part, and what the connector does, it goes into Aras, creates those parts for the corresponding document, and places it in Aras. So we'll go back into Aras. I'll switch back here into my Aras Innovator. I'll go ahead and close some of these documents, come back to my parts, and I'll quickly refresh here, and you'll notice that the items now have automatically gotten created based on the assembly structure. And if we open that up, we'll open the assembly, you notice that we now, actually let me refresh that. Back to the CAD documents here. Show the CAD documents. Click create CAD, and we'll look at the assembly. And you'll notice now that the part item has automatically been assigned to that CAD document. And if I clicked on the part, automatically I pulled some information on it. Notice the part number is automatically, in this case, we have the part number and the CAD document automatically being matched. Of course, you can customize this to whatever desire for your organization, but it's something nice to have to be able to customize those processes. The description, in this case name and long description, is automatically mapped. It pulled out from the CAD information. If we come back into the CAD Documents tab, you'll notice that the assembly is automatically linked for that CAD document. So we have a container now we have a container for our CAD item, we have a container for our part item for managing those CAD files. One other thing I want to mention here is that in the situations where we have a drawing, so I'll go ahead and open a drawing for this assembly. We also have the capabilities to match, to update the title block information, have the proper mapping defined for those information to come through automatically for you. And those drawing as well gets automatically related assembly or the related part item for when it's saved into Aras. So we'll go ahead and walk through that process. So I'll go ahead and hit save on this CAD drawing. And you'll notice it pulls the entire structure, but since I've already saved the assembly, it's not going to grab those other parts because they're no longer needed. Go ahead and hit save. Wait for that to complete. Does some reload behind the scenes to pull the proper information. We'll go through back into Aras Innovator, and we'll come back here and do a refresh. And I'll go ahead and look at that assembly and the item. Do a refresh on that. 1 second. Refresh. Okay, you'll notice that the PDF now has automatically been created for all the subcomponents. I'll go ahead and look at the items. And I'll look at, notice that we don't have any BOM structure at the moment because we haven't created any BOM. That will be the next step. But at this point, you'll notice that the drawing has been automatically linked to that assembly item. So now we have a drawing in the assembly tied to that item, the assembly item, as well as automatic 3D PDFs have been created, and a 2D PDF for the drawing has been created for those files. And that's all done automatically for you. Okay, so let's do a quick recap. So what we've done is we've gone through and we've took a brand new assembly and we saved the data into Innovator. Second, of course, we could have done all these steps together, but we're dividing into pieces so we can really see the process. Is that second, we went through and created an item number for each of the CAD documents in its container. And the next step is to create the BOM. So we'll go ahead and switch back over here to the assembly. Inside my connector, I have this button for Create BOM. I'll go through, and what happens is that the connector is going to traverse the structure and understand the structure and pull out the correct BOM information and push that into Innovator. So if we go ahead and switch back into Innovator, I'll do a refresh here. And I'll go back and look at my assembly again and pull the item. So now you'll notice that the information has automatically been pulled in, and we have all those components that make up the assembly populated into BOM. And ultimately we have also the BOM structure. So if you wanted to see the structure where there were sub-assemblies, you can see all that information for the corresponding items. And that's how easy it is to create a part BOM. Really, the connector takes advantage of the CAD structures, uses the powerful Aras API for CAD, and be able to pull that information into Aras to have it all consistently inside Aras Innovator. It's important to mention that all this can be done again in one step, but we went through the separate steps to really highlight how easy it is to create the part and CAD document structure inside Aras. Now we've created our parts, we have a BOM defined. The next step is to release this assembly. It's a really simple process. What we'll do now is we'll go through and look at the change process for releasing a design. Of course, I'm going to go through here as administrator, and I'm going to do this all in one shot to expedite the process. But of course, the process would go through a workflow, and would take a lot more folks in the organization to go through and approve the process. But for our case here, I'm going to go ahead and do it all one shot to expedite the process. So I'll go through and I'll do a refresh here, and I'll grab my items, and I'm going to right click on it, and I'm going to say add items to change. And it's going to tell me, okay, you want to create a change. In this case, I'm going to pick a simple ECO, and we're going to create a new one. So I'll hit OK on that. You'll notice that now the ECO form has come up. It's asking me for a description. I'm going to say release of train assembly. And change, we'll just set initial. Okay, and hit save on that. And I'm also going to go back into the CAD documents, and I'm going to grab the corresponding CAD documents. So I'll go ahead and grab this and go to here. We'll add that to change. It's simple. And this time we already know it's the, so just quickly, I already have ECO here. I know the number is this ECO, so I'll go in and add to that change. We'll say it's a simple ECO. It's that guy. We're going to add it in. So now we have all those documents and the affected items on the ECO. I'll simply go ahead and hit save. Hit complete here. Now at this point, notification will go out to the corresponding folks, different areas in the organization, and they would either get the notification through their in-basket. So if I go into my innovator and click my in-basket and do a refresh here, you'll notice that I have a change here that's pending, and or alternatively they can also receive an email with the notification. So I'll go through here and hit the complete task. And I'm just going to move it along here so we can quickly move the ECO through. So I'm going to go ahead and hit the submit, which is the first part. Hit complete on that. And at this point, notification will go out to the corresponding team. I'm going to go ahead and hit one more time, hit the complete task here. I'm going to say it's complete. And one last time, I'm going to go ahead and say, okay, we're going to fast track it to approve. And at this point, it's going to require my signature to finalize that, and I'm going to say complete. So do a refresh on that. So let's go back and recap. So what we did is basically took the items and the CAD documents, we threw it on the workflow, we took it through release. So if you go back into our part structure and we do a refresh here and we look, okay, stay here. Come back here. Do a refresh. And sort into Aras. And you'll notice now that all of our items have been released, and it's complete from the item perspective as well. If we go back to the CAD, you'll notice the same thing. Now it's officially released. That is how simple it is to take a design from concept all the way to release in Aras Innovator using the connector to really simplify the process. One of the things here that I missed that I wanted to mention real quickly about the capabilities of the connector is the fact that we also have the ability to add non-CAD items into the bill of materials. So the connector is intelligent enough to understand that CAD-only specific items such as skeleton, will be excluded and not be part of the BOM. This is important to mention because especially for companies who are engaging on top-down design, they're using a lot of the CAD tools to capture design intent. The connector is intelligent enough to understand some of those design functions and only allow for specific CAD structure to be put in and exclude things like skeleton that does not belong inside of a BOM to be reported. And of course, we can manually add items such as bulk items, grease, tape, etc. And the connector will understand that process and not remove it as we do updates. It will only focus on the CAD structure and not anything that's been added manually. Okay, so let's do a quick recap and bring this all together. We've gone ahead and we've taken an assembly, we've took it through, we've created a document item, we created a part item, we've put it through a change workflow, we've released it, now it's completely released. So the next step is what happens when there's a change, and that needs to happen, and we need to make a change to that assembly. So we have to go through and put it on a new ECO and release the item. Okay. So what I'll do is I'll go ahead and clean this, just close this assembly real quickly. And I'm just going to come in my workspace here and clean up my workspace a little bit. And I'm going to go back into Innovator, and we're going to look at our CAD documents. I'll go ahead and close this out. So I'll go back to my parts, and I know that this is the assembly that I'm interested in making a change. So I will go ahead and grab the assembly items. I'm going to go ahead and right click on it, say again, add to change. Create a new simple CO, say OK to that, give it some change, and say update, description, we'll just say update, crane assembly, spell there. Go ahead as well and hit save on that. And grab the CAD documents. Add that to change. So we know it's going to be 107, so I'm going to go ahead and assign that to change. Simply CO 7, hit OK. Okay. So we have the items that's going to be affected, and we're going to make a change. In this case, you will notice the old revision, and it's going to go to A to B. We'll go ahead and make these into changes as opposed to adding, that we're going to make some change to the assembly as opposed to adding one-to-one components. Okay, I'll hit save on that. Just take the spelling real quickly. And now that I've made a change and saved it, I'll come back into my in basket. I'll do a refresh on that. You notice that I have now the change. Now at this point, I'm going to go ahead and move it along the workflow. And the first thing I'm going to do is submit it. So the moment I hit submit, the notifications will go out to the designer, in this case an engineer, that a new change is coming through and what's expected for the change, and they can begin working on the change. So I'll go ahead and unlock that and say complete. Okay, so now if we look closely at the Innovator, you'll notice that from a document perspective, we have the item has now moved from release to preliminary. We can begin working from the CAD side. And to do so in CAD, it's a pretty straightforward process. I would come in here and do a load from CAD and be able to go in and search for that item that I need or the CAD document that I need and be able to pull it in to make the modifications. I'll expand this real quickly. We understand that the assembly that we're interested in making a change to, and of course we can see all the states here. It's all available to us. It's the crane assembly hook that I'm interested. I'm going to go ahead and hit OK on this, and it's going to load it into my CAD session. I can go in and begin to make a change. The important thing about the connector as well is that it allows us to insert components directly into the CAD session from Innovator. Ultimately, we can also do it locally, but in this case, let's say I needed to make an addition to this, and we'll go ahead and look for a document that I need, and I'm going to say I need some hexagon screw, maybe. Oops. Do a search for that, and I found one. I'm going to go ahead and say OK, and I'm going to insert it. Say load. And you'll notice that in this case, okay, I'll go through and I can go through and assemble it to the right location, but the nut has come in and I have it inside my assembly pool directly from Innovator. So at this point, the process really becomes the same. We've gone through the process of releasing and new release the assembly, make a change to the assembly, and submit it back in, and simply hitting the save and submitting that information back in. You can see how easily it is to, with the connector, to really manage your data inside Aras and be able to control fully without having impact to your CAD session. All is embedded inside CAD, so engineers can really focus on CAD and drive the design, but still be powered behind with Aras Innovator as your CAD data management tool. And that really completes the presentation. We'll open up for first question.
All right, thank you, Raul. Make sure to enter in any questions you might have into the Q&A panel after seeing that demonstration. We have a few submitted questions now, so let's get to those. How to add external CAD file in mass, for example, 300 parts of step file or key creator file.
So we could always do a bulk load from Aras side, so we have tools to do that, but using the connector as well. The connector really is the preferred part to load large assemblies, but bulk items can also be loaded manually from what's scripted from the innovator side.
Okay. Are the connectors Aras connectors or are they third party?
So, good question. We have partner connectors, so we partner with all different partner industries, and they provide the connectors, but of course we have a tight relationship with them. We're constantly making sure that the latest features of the innovator gets pushed to those connectors, and correspondingly they work nice and tight with the connector.
All right, I'm seeing a lot of questions come in, and unfortunately we're at time, so I'm going to take one more, and then Raul will be in touch to answer all of your questions after the demo. Last question. Is it mandatory to have same CAD document number and part number for connector to function properly?
No, all those are customizable. It's a very good question. In our case, I had it mapped to be the same, but those all depend on your business process and it can be customized. One thing to mention is that Aras is really flexible and it's really made to adjust your organizational needs, so it can be configured to meet whatever your needs are.
All right, thank you everyone for your questions, and again I apologize for any that we didn't get to today. I'm going to leave you with what is upcoming. We'll be having a special change in the schedule with a demo next week on June 21st, and we will be going over effectively leveraging your EBOMs to create error-free MBOMs integrated with manufacturing work instructions. And then on July 12th, we'll be discussing visualizing complex product data using query definition and tree grid views. Again, you can register for upcoming webinars and view any past webinars at www.aras.com/demo-series. We would love for you all to join the Open Aras PLM community. We've got blogs, knowledge bases with a lot of good information, forums, community projects for you to access and contribute to when ready. Be sure to follow Aras on social. You can find us on LinkedIn, Twitter, and Facebook, where we are looking to share with the community industry-related news on articles, latest information on Aras news, products, assets, and more. With that, we thank you for joining us today and look forward to having you on next time. Thank you and have a good day.